Hey everybody. So this is the problem that I started talking about last time in class. And I promised you that I would find out a little more about what the IB expectations are with respect to the vocabulary and what you need to be able to do with this problem. And what I learned is that you do need to understand this idea of interest and calculating interest on a loan. You do need to understand this term PA, or per annum, to know that that means it's interest per year. And you need to know the idea of compounding, which just means how often are you calculating, not compounding, but calculating, how often are you calculating that interest, so that you know when the bank or whoever is giving you this loan, when they're going to calculate the amount that is owed. And so let's talk a little bit about that. We discussed that 12% per annum means 12% per year. So if the interest was calculated over the course of the year, then this would mean that at the end of 1 year, you would owe $1,500 times 1.12, which would give you that total, the total amount at the end of that first year. But the complication here is that the interest is calculated monthly. That means every month you're going to calculate how much is owed and increase the amount that is owed by that amount. And what we discussed in class was that 12% per year in this situation really means 1% per month. And so what I've done is I've actually put together a way to look at this using TI-nSpire. If you are in the home menu here, you can select the spreadsheet, and it will take you to this view. So we'll go to the spreadsheet, and I'm going to go to this tab that I've already set up. And so I put up months, and I put amount, and I put 1,500 in this cell because at 0 months, so at the very beginning of this problem, our friend owes 1,500. If I wanted to calculate after 1 month how much is owed, I can enter a formula, and I can say that this is the amount that was previously owed, and then I can multiply that amount by 1.01, because that increases the amount by 1%. And so after 2 months, because again, the bank is going to calculate this amount every month, the bank is going to say how much is owed. So equal sign, the previous amount was what is in cell B3, so I'm going to do B3, and I'm going to multiply that by 1.01 to calculate the new amount that is owed. And what's neat about the spreadsheet is I can actually go all the way down and just drag this and see how much would be owed if I were to start paying this back after 24 months. So we'll delete this one so we can see after 24 months, if I paid nothing, this would be $1,904.6, and I think this question asks for the nearest dollar, so it would be rounded up to 1905. All right, so now let's take a look at what we would do if instead of just waiting the 24 months to pay this off, what would happen if instead each month we paid off a certain amount of this loan. So for example, if I wanted to calculate the amount that I owed, let's say instead what I would want to do is, let's say that I pay maybe $100 per month. So I'm going to subtract from the amount that was owed $100. And so if we think about that, that means that's $1,400 that are left, and I'm going to take that $1,400 and multiply it by 1.01, and I get this amount. And I haven't continued this formula, so let's drag this down one more and talk through what this means. So again, previous month I owed $1,414, but let's say I reduce that amount by 100, so I'm now down to $1,314, and I'm going to take that amount and multiply it by 1.01 to find the new amount that I owe. And let me drag down that formula, and we'll see what happens. So you'll notice if that is what I do, that if I were to continue doing that for 24 months as I scroll down, I actually end up paying way more than I need to, because at a certain point, and I can pan down to find out when, let's see, after between 16 and 17 months, I have paid off that loan. I paid off everything. And so this means, because the original problem said it should take 24 months to pay this thing off, that's too much. So I'm not going to pay 100 every month. So let's go back up to the top on this experiment. Let's play with the numbers. And let's say that instead, maybe I pay 50 per month. And let's drag that all the way down. So if I drag that all the way down to 24, so that's 24 months, I actually see that I haven't paid off the amount. I still owe, after 24 months, $542. So we can see that 100 per month, I'm paying too much, but 50 per month, I'm paying not enough. And so I've established that I'm probably going to be paying between $50 and $100 per month in order to pay this off in exactly 24 months. So let's look at what we can do now to figure out the exact amount that I should pay per month to pay it off in exactly 24 months. So let's see if we can use our skills and maybe some of our series and sequence knowledge to figure out this problem. So we started looking at this problem this way. We first said after 1 month, so 1 month, the amount we owed, so we had 1,500, we were multiplying it by 1.01, but then we were subtracting 100 to figure out how much was left for the next month. And so once we had that amount, when we got to the next month, it looked like this. So it was going to be that previous amount, which was 1,500 times 1.01 minus 100. So it was going to be that amount, that entire amount, which is what we were left, and then we were going to subtract another, we were going to take that amount, multiply it by 1.01, and then we're going to subtract another 100. Okay? And so the month 3, it was going to be the same sort of thing. So the previous amount, 1,500 times 1.01 minus 100, minus 100 times 1.01 minus 100, so that's the previous amount. We're going to multiply that by 1.01 because that's the interest that we are owed, and then we're going to subtract 100. So you see, each month we're taking the previous amount, multiplying it by 100, and subtracting whatever our monthly payment was. But we figured out that 100 is too much. Okay, we want to know whether it should, we want to know what payment should be paid each month. So 100 was too much because we paid it off in 16 months. 50 was too little. And we know our answer is somewhere between those two. So now that we see what this is doing, this is where we introduce our variable. And so instead of putting 100 each time, we can just say that this amount is going to be x. So I'm going to put that in a slightly different color. So this is minus x, this is minus x, and this is minus x. And so we're continually subtracting x. And we can kind of see a pattern that is coming out of this. Because if we think about it, we're always taking 1,500 and multiplying it by 1.01. If we were to distribute in each of these cases, it's 1,500 times 1.01 times however many months have gone by. So for month 3, we're taking 1,500 and multiplying it by 1.01 once, twice, 3 times. For 2 months, we're multiplying it by once, twice. And for 1 month, we're multiplying it by 1.01 once. So really, this is 1,500 times 1.01, we can say n, where n is the number of months. And we know that we want this number to be 24 because we want to pay this off over 24 months. Okay, now this is where it gets a little complicated because we have to figure out what's actually happening here. So this is going to be x times 1.01 to the 23rd. If we think about how this pattern is going to continue, because in this one we were multiplying. Let's go to a different color for the highlighter. In this one we were multiplying 1.01 times x once, twice. In this one we were multiplying it once, and in this one we were multiplying it not at all. And so this pattern is going to continue. This is minus x times 1.01 to the 23rd. Then we're going to subtract 1.01 to the 22nd times x minus 1.01 to the 21st times x, and we're going to keep going until we get just to x, and that's going to be equal to 0. And the reason we want that to be equal to 0 is after 24 months, the total that is owed should be back down to 0. And the thing that I want to highlight is that this quantity right here is a geometric series. We can factor out x and be left with this quantity, 1.01 to the 23rd, plus 1.01 to the 22nd, and so on, all the way up to 1, because we're going up to this last term here of negative x. So we're taking all of this. We have 1,500 times 1.01 to the 24. That's still there. And we set that equal to 0. This is now an equation to solve. And this is how this applies to your knowledge in IB Math, because you have learned some tools to evaluate this series right here. This is a geometric series. Our R value is 1.01. And we know that our A value is really just 1, so we're going to be able to use our sum formula to find what that is. So we have 1,500 times 1.01 to the 24 minus x times whatever s to the 24 is, and that's equal to 0. We can use the calculator to find out that s to the 24. We could add these up using the calculator features, or we could use our formula. And our formula says that this is going to be r to the n, that's 24 minus 1, over r minus 1. Now, this number we don't want to evaluate. We want to store it because we want to ultimately solve this equation. So let's go back to the calculator and look at how we would actually do that on the calculator to find our answer. All right, so we're back here on the TI-nSpire. Let's go back to the home screen. And let's go to our calculate. We have some great capabilities of solving equations. And so we're going to go to algebra. We're going to go to numerical solve. And we're going to type in our equation now, the one that we just wrote down. And so we're going to put in 1,500 times 1.01 to the 24. And I'm going to subtract x times, and I'm going to just put directly that entire expression in, 1.01 to the 24 minus 1 over, and I'm going to put this in parentheses, 1.01 minus 1. I think that covers the entire thing, equals 0. And I'm going to put my variable, which is x, because that's the variable I'm solving for, hit enter, and this solves the entire equation for me. I get 70.61. This 70.61 is the monthly payment that I would be making every month. So $70.61 dollars per month will make it so that after 24 months, the amount owed goes to zero. If we go back to the question, we can see this is asking us to find the amount that each month we need to pay. And so we have found that amount of x being 70.61. And then this says evaluate how much to the nearest dollar we actually have to pay for the apartment. And we can also do this right on the calculator, because if we're paying 70.61 per month for 24 months, this tells us that we owe $1694.64, which we would round to the nearest dollar, and that would be $16.95 as our solution. So there was a lot of explanation there, but that's how we go about a question like this that brings in some of our knowledge of geometric series. And ultimately, this is a great opportunity to learn to use the calculator to do some of the work for us. So I hope this helps. Let me know if you have any questions.